For the past few days, I have been learning about an IC which is in the existence in almost every electronic circuits without any complaint, without any modifications since the 70s. Maker's favorite, the NE555 timer IC. I'm pretty sure if you are into electronics, you must have encountered this name before. But if not, then welcome to the second episode of Electronic Basics. We all know signals are heartbeat of electronic circuits, and every signal consists of two things: voltage level and time. Here, NE555, the Lord NE555 comes into the picture. As the name suggests, it's a timer which is well-known, highly stable integrated circuit that can produce accurate time delays and oscillations. So that is the reason why this masterpiece IC can be found in many electronic devices, starting from home appliances to even a spacecraft as well. All of this magic happening with just 8 pins. Yes, because it comes with 8-pin dual inline package where, as always, ground and VCC for powering the circuit. Its operating voltage ranges from 5 volt to 16 volts. Pin 3 is the output pin where you can observe the output waveform from the circuit, and a reset pin is to reset the complete circuit. It is an active low pin, so connecting it to ground will reset the whole circuit. Now it is important to note that this timer IC don't have any internal clock circuit. Wait, what? Then how it is performing the timing operations? Well, for that case, external RC components are required. Voltage levels at trigger and threshold pin decides the nature of the output waveform, and voltage levels at these two pins are decided by the charging and discharging of the capacitor. By changing the R and C values, you can change the frequency or duty cycle of the waveform. Control pin is used for changing the threshold voltage, and the discharge pin, as you are already smart, you might have guessed, it is used for discharging the timing capacitor. So that was complete story from outside the NE555. Now I'm not going into the block diagram, but it contains comparators, flip-flop and transistor for performing all the operations. But as a rule of thumb, you can always remember, whenever trigger pin goes low, set the output pin high and discharge pin open. And whenever threshold pin goes high or reset pin goes low, sets the output and discharge pin low again. So that's how the charging and discharging of the capacitor happens, and NE555 switches the output. And based upon the nature of the output, NE555 generally operates in 3 modes: bistable, monostable and astable. Coming to very first mode, this timer is a digital IC, so contains only 2 output state. And in bistable mode, both the output states are stable. At each interrupt, the output changes from one state to another. Here I am using the push buttons as external interrupt, but it can be given from any microcontroller or any sensor to trigger the output. Second mode in the list is monostable. Yes, you are right. This configuration consists of only one stable state and another one is unstable state. User can decide which state will be stable. As it contains one stable state, so only one external interrupt is required. At the application of this external interrupt, the timer output goes to unstable state, wait for T second and again jump back to its stable state. This T is given as 1.1 times R1 into C1. Now last mode is astable mode. This means there will be no stable output, so the output will be swinging between high and low. This mode is pretty much autonomous, so don't need any external interrupt to switch the output. And its unstable output characteristic is used as a clock or square wave output for many applications. This was just a brief introduction to the NE555 timer. There is so much more to explore. Be sure to check out the important links I have posted in the description. I will be sharing more exciting content in the basic electronics series, so make sure to subscribe for future updates. Thanks for watching and see you in the next video.